Welcome to Algebra 1, Unit 6, Lesson 16, Practice Problems. Which equation can be represented by a graph with a vertex at 1, 3? So, what you need to remember on this problem is the vertex points are at H, K. And the vertex form is y equals a times x minus h squared plus k. So if we substitute these values of 1 and 3, it should look something like x minus 1 squared plus 3. And the only option that has a minus 1 and a plus 3 is option A. If you have any question about how to identify the vertex form of the quadratic equation when you are given the coordinates for the vertex, please use class time to ask for further clarification. Where is the vertex of the graph that represents y equals x minus 2 squared minus 8? So remember, vertex form is y equals a times x minus h squared plus k. And the vertex is at the point hk. So for number 1, h is going to be 2. And k is going to be negative 8. So positive 2, negative 8 is the vertex. Number 2, where is the y-intercept? So remember that y-intercepts have an x value of 0. So if we plug 0 into the equation, y equals 0 minus 2 squared minus 8. 0 minus 2 is negative 2. Negative 2 squared is 4. And 4 minus 8 is negative 4. So the y-intercept is at the point 0, negative 4. And that point would be right here on the y-axis. Number 3, identify one other point on the graph of the equation. Explain or show how you know. If the y-intercept is 2 units left and 4 units up from the vertex, there is a point two units right and 4 units up from the vertex. At +4, -4. Because quadratic equations are graphed by parabolas, and parabolas are symmetric as they move away from the vertex. And number 4, sketch a graph that represents the equation. So I plotted the vertex in red, the y-intercept in blue, and the symmetrical point in orange. Now I can draw my parabola that connects them. If you have any questions about how to use the vertex form of a quadratic equation to find the vertex, to find the y-intercept, or to find a third point using symmetry, or how to graph from the vertex form, please use class time to ask for further clarification. The function v is defined by v of x equals 1/2 times x plus 5 squared minus 7. Without graphing, determine if the vertex of the graph representing v shows the minimum or maximum value of the function. Explain how you know. So remember that this is factored form. And factored form is y equals a times x minus h squared plus k. If a is positive, the graph opens upward. If the graph opens upward, the vertex shows the minimum value of the function. Since our A is positive 1/2, then this graph opens upward, and because the graph opens upward, the vertex shows the minimum value of the function. If you have any questions about how to use the vertex form of a quadratic equation to determine whether the graph opens upward or downward, and to determine if the vertex represents a minimum or a maximum, please use class time to ask for clarification. Match each graph to an equation that represents it. They are giving us each equation in vertex form. Vertex form is A times x minus h squared plus k. Now all four of them have the same vertex, so h and k are not important here. What we're comparing is going to be A. If A is positive, graph opens up. So A and C are going to be the positive A's. If A is negative, graph opens down. That will be choices B and D. We also need to understand the larger A is, the faster Y grows, and the steeper the graph. So, if we're looking at A and C, they open up, so A is positive. So A and C match with 2 and 3. In 2, our A is 1 or 6. Since C is steeper, it must have the bigger A value. So C is going to match with 3. 6 is greater than 1, so the graph is steeper. That means A must match with number 2. Next, we're going to compare B and D. B and D open downward, so A must be negative, so B and D must match with 1 and 4. We can see that 2 is greater than 1/3, so the graph is steeper, so that means B, which is a steeper parabola, matches number 1, while D, which is a shallower or wider parabola, must match number 4. If you have any questions about how to match graphs to the vertex form of the quadratic equation, please use class time to ask for further clarification.